In previous lesson, we studied that we can expand binomial expressions using Pascal's triangle. And also we mentioned that we can also expand binomial expressions using combination. What's that? That's in fact it is a relation between Pascal's triangle and combination. What's that relation? Let us show it by an example. If you want to find the fourth entry in 8 row, so it will be combination of 3 from 8. Combination of 3 choosing 8 or from 8. And 8 shows the number of row and 3 shows the number of entry minus 1 or 1 less than the number of entry. And the other characteristic of Pascal's triangle was that the sum of the terms in nth row is 2 to the power of n, which this one is the total number of subsets which is chosen from a set with n elements. And also the symmetrical property of Pascal's triangle is also related to combination rule. What's that? In combination, as you remember, the combination of r chosen from n was equal to the combination of n minus r chosen from n. So let's show it in a table. The Pascal's triangle by combination. If n and r, both of them are integer, and r is between 0 and n, so the Pascal's triangle can be shown by like this. The number of row is always the first component of the combination. As you see in the third row, 3, 3, 3, 3, and the fifth row, 5, 5, 5, 5. But the second component in here, or the number of elements which are chosen from n, or number of row, is starting from 0 and increasing 1 by 1. For example, in here, 0, the combination of 0 from 0. The entry for row 0 is combination of 0 chosen from 0. The entries for row 1 is the combination of 0 chosen from 1, 1 chosen from 1. Or the entries for third row is the combination of 0 from 3, a combination of 1 from 3, the combination of 2 from 3, the combination of 3 chosen from 3. Or for fifth one, combination of 0 from 5, 1 from 5, 2 from 5, 3 from 5, 4 from 5, and 5 from 5. Let's generalize it. If we generalize the triangle, we can expand any binomial expression x plus y to the power of n as combination of 0 from n times x to the power of n plus combination of 1 from n times x to the power of n minus 1 times y plus combination of 2 from n times x to the power of n minus 2 times y square, and the general term will be n combination of n minus 1 from n times x to the power of n minus 1 times y to the power of n minus 1. Or we can say that the power of y, or second component, is always the second component of the combination. But the power of first term, x is always first component minus second component. And the coefficients can be formed by using the Pascal's triangle that we explained it above. For example, the question asks us to expand x plus y completely to the power of 3 by using Pascal's triangle. Let's solve this one. Yeah, let's expand x plus y completely to the power of 3 using combination. X plus y completely to the power of 3 as n is equal to 3. So we can use the combination of 3 from 0, 0 from 3, 1 from 3, 2 from 3, and 3 from 3. And the power also like that. So a combination of 0 from, 3. So 0 from 3 times x to the power of 3 minus 0, which is 3 times y to the power of 0, plus combination of 1 from 3 times 3 extra power of 3 minus 1 to y to the power of 1 plus combination of 2 from 3 times x to the power of 3 minus 2 is 1 times y to the power of 2 plus the combination of 3 from 3 times x to the power of 3 minus 3 0 times y to the power of 3, and it's equal to a combination of 3 from 0 is 1 times x cubed times y to the power of 0 is 1, and x to the power of 0 is also 1, plus combination of 3 from 1 is also 3 times x squared y to the power of 1, plus combination of 3 from 2 from 3 is also 3, so 3 times x times y square plus combination of 3 from 3 is 1 times y cubed is equal to y cubed, or let's write it simple in simplest form. It's equal to x cubed plus 3x square y plus 3xy square plus y cubed is the expansion of the first example. Yeah, the second example, the question asks us to expand 2a minus b completely to the power of 4 using combination. Let's expand it by combination. We should use this formula or apply this formula. We can write 2a minus b as 2a plus negative b completely to the power of 4 is equal to combination of 0 from 4 times 2a completely to the power of 4 plus combination of 1 from 4 times 2a to the power of 4 minus 1, 3 times negative b to the power of 1. Yeah, the power of the first term is decreasing 1 by 1. The power of the second term is increasing 1 by 1. And first term it was 0, so I don't write it. But the second term it becomes 1. Plus, and let's continue, combination of 2 from 4 times 2a completely to the power of 2 times negative b complete square plus combination of 3 from 4 times 2a completely to the power of 1 times negative b completely to the power of 3 plus combination of 4 from 4 times 2a to the power of 0 is 1. I don't write it, so negative b completely to the power of 4. Yeah, let's continue. Continue it. Combination of 4 from 0 is 1, so 2a to the power of 2a completely to the power of 4 plus combination of 4 from 1 is 4 times 2a completely to the power of 3 times negative b to the power of 1 is negative, so it will make this positive or addition change to subtraction or negative. Plus combination of 4 from 2 is 4 factorial over 2 factorial times 2 factorial, as 4 factorial is 24 over 2 factorial, 2 times 4, 6. 6 times 2 completely to the power of 2 times negative b completely to the power of 2 is b square plus, or as negative b cubed is negative, so negative will become it, negative times positive will become negative. Combination of 4 from 3 is again 4 times 2a times 2a to the power of 1 is 2a times negative b cubed. As we multiply negative by addition, it make it negative subtraction, b cubed plus 4 combination of 4 from 4 is 1 times negative b complete to the power of 4 is as power is an even number, so b to the power of 4. Let's simplify it, the last expression. I mean this one. 2a complete to the power of 4 is 16a to the power of 4 minus 2a completed to the power of 3 is 8a cubed to times a, here we have b also. 4 times 8 is 32 a cubed b, plus 2a complete square is 4a square, so 6 times 4 is 24 a square b square. Negative 4 times 2 is negative 8 minus 8 a b cubed plus b to the power of 4 is the result of the second example, I mean this one. Let's solve the third one. The third one, as you see, square root of x plus 1 over x completed to the power of 5. The question asks us to expand it using binomial, using combination. Square root of x plus 1 over x completed to the power of 5 is equal to, again we use this formula, combination of 0 from 5, let me clean this part, 0 from 5 times the square root of x completed to the power of 5 plus combination of 1 from 5 times square root of x completed to the power of 4 times 1 over x completed to the power of 1 plus combination of 2 from 5 times square root of x completely to the power of 3 times 1 over x to the power of 2. The power of square root of x is, or power of first term is decreasing 1 by 1, and power of second term is increasing 1 by 1, plus combination of 3 from 5 times square root of x square times 1 over x completely cubed, plus combination of 4 from 5 times square root of x completely to the power of 1 times 1 over x completely to the power of 4, plus combination of 5 from 5 times square root of x completely to the power of 0, or we don't need to write it, so I omit this one, 1 over x completely to the power of 5. Let's simplify them. Combination of 0 from 5 is 1, so square root of x completely to the power of 5. Let's write it. Square root of 5 completely to the power of 5, plus combination of 1 from 5 is 5 times square root of x to the power of 4 plus times 1 over x plus combination of 2 from 5 is I think 10 times cubic root of x over x square, plus combination of 5 from 3 is also 10 times cubic square root of x complete square over x cubed, plus combination of 4 from 5 is 5 times square root of x over x to the power of 4, plus combination of 5 from 5 is 1 over x cubed. I'm sorry, x to the power of 5. So let's simplify them. Square root of 5, we can write it as x square, square root of x plus square root of x to the power of 4 is x square, 5 times x square over x, plus 10 times x cubed, we can write it as x square root of x over x square, plus 10 times square root of x, I think square and square root cancelled, x over x cubed will be left, plus 5 times square root of x over x to the power of 5 plus 1 over x to the power of 5. And also we can simplify it a little more, so square root and square, x square and x cancelled, and this x with square cancelled, and this x will become x square, and we can now simplify the square root, so let's continue. X square times x square root of x plus 5x plus 10 times square root of x over x plus 10 times 1 over x squared plus 5 times square root of x over x to the power of 4 plus 1 over x to the power of 5 is the expansion of this binomial expansion. By using the relation between combination and Pascal's triangle, we can also calculate or find any term of the expansion. For example, if we want to find the odd term of x plus y complete to the power of n, so we can find it from this formula. Combination of r minus 1 from n times x to the power of n minus r minus 1 times y to the power of r minus 1. So if we simplify it, a combination of r minus 1 from n times x to the power of n minus r plus 1 times y to the power of r minus 1. I think we have mentioned this one, that the power of x is the difference of the second component from first component, and the power of the y or second term is the second component of the combination. For example, find the ninth term in the expansion of a plus b complete to the power of 12. In here, r is equal to 9. R is equal to 9, and the power of the binomial is 12, so n is equal to 12. By using the previous formula, we can write it as a combination of, and let me find r minus 1 also. R minus 1 is equal to 9 minus 1 is equal to 8. So the ninth term of this binomial expansion is combination of 8 from 12 times x to the power of 12 minus 8 times y to the power of 8. 8. And it's equal to combination of 12 from 8. We can write as 12 times 11 times 10 times 9 times 8 factorial over 12 minus 8 factorial, which is 4 factorial, times 8 factorial. 8 factorial and 8 factorial cancel there. Times x to the power of 4 times y to the power of 8. As you see, and the sum of the powers of x and y is equal to 12, or to the original power. And if we simplify them, if we calculate them, we will find the result as 295 times x to the power of 4 times y to the power of 8 will be the ninth term of this expansion. The next example asks us to find the sixth term of 2x plus y complete to the power of 9, or the expansion of this one, it means. So in here, first of all, n is equal to 9. Let's write it. N is equal to 9. And r is equal to 6, because the question asks us the sixth term. And r minus 1 is equal to 6 minus 1, which is equal to 5. So let's use the previous formula. What was the formula? Remember it, combination of 5 from 9, times 2x, the first term is 2x in binomial, to the power of 9 minus 5 times the y to the power of 5. If we expand them, if we simplify them, so a combination of 5 from 9 is 9 factorial over 9 minus 5 factorial times 5 factorial times 2x completed to the power of 4 times y to the power of 5. And if we simplify them, calculate them, we will get 216 x to the power of 4 times y to the power of 5 will be the sixth term of 2x plus y complete to the power of 9. The expansion of that.